Hi, mathletes. Make sure you have this handout as you go through this video. We're going to talk about rational exponents, what that means today. Rational exponents means fractional exponents. We're going to review simplifying radicals because that's going to help us when we have rational exponents as well. We're going to convert between the two. In addition to reviewing simplifying regular square roots, we're going to talk about how do you square root a cube root, or how do you simplify a cube root or a sixth root like we have here. We're going to look at when we have these fractional exponents or rational exponents, how do we use our properties to simplify those and convert between radicals and exponents. So first thing, let's write on our paper that rational exponent simply means fractional. And we'll talk about that. I'm going to put this in the right margin over here. You probably have room on your paper to do the same. So the property is if I have x to the m over n power, that is going to be the top part. X to the m is just a regular power, and that can be thought of as to the 1/nth power, which is the same thing as saying the nth root of that. So the top part is always your power, just like normal, and the bottom part is your radical or your root. For example, if you have x to the 2/3 power, that is going to be the same as x squared, and then it's going to be cube rooted. The 3 that's in the bottom here is your index. That's the little number here of the type of root that we're taking. Taking a look at this second one, it is going to be 4 to the 3rd power, and then that is square rooted. 4 to the 3rd power is the same thing as 64, and that's being square rooted. The square root of 64 is 8, so it can help us simplify to be able to break this down. Let's take a look at this first simplify section. So square roots, we're looking for perfect squares or pairs, because square is something times itself, so it's a pair. So if I take 8 and I break that down into its primes, 8 can be divided by 2, that gives me 4. 4 can also be divided by 2, that gives me 2. Now I have 2 times 2 times 2 as the prime factors of 8. And I have 2 times 2, which is a perfect square. Square rooted would be 2. That comes on the outside. What is left over is left on the inside. So the square root of 8 is the same thing as 2 root 2. And you can do that for any pair, any square root. When we get to something that is not a perfect square, and we'll talk about also, what to do when you have variables in there. But when you have you have a different type of square root. So this is a cube root. That means we're looking for perfect cubes. You can still get to the same things by breaking down, like that 625. I can break that down and say, okay, that's divisible by 5, and that's going to give me 125. 125 is divisible by 5, and that's going to give me 25. That is also divisible by 5, which gives me 5. So 625 is 5 times 5 times 5 times 5. We are looking for groups of 3, perfect cubes. So I can take 3 of these out. So these 3 can be cube rooted out. It leaves underneath the radical 1, 5, and also it leaves us the r squared. Because there's only 2 r's, r times r, none of those r's can come out. If there had been 3 of them, I would group those 3, and that would come out here with the 5 on the outside. So this would be 5 times the cube root of 5r squared is its simplified form here. You are going to simplify the rest of these. Some of them are perfect squares, but most of them are going to simplify like I've shown you here. Let's take a look at this next section. Write each expression in exponential form. we are just going to take at our power is going on top. So I'm going to take 10x, and it is going to be raised to the 8th power, because that is our power. And our denominator of our rational expression or our fraction is going to be the root part, and that's going to go down here, and that's where my 5 is going to go. So that's 10x all raised to the 8/5 power. Remember, if there's no number here, that it is, if there's no number here, that there is like a little 2 in here, if that helps you. So if this is 7x, it is being raised to the 5th power, and the radical is a square root, so that means it's going to be a 2 right there. So I'm sliding my paper down to the next simplify section. So when we have a power raised to a power, we can distribute that over both of those pieces, so that this is 81 to the 3/2 power and a squared to the 3/2 power. And it's helpful to think of 81 as 9 squared, because when you have a power raised to another power, you're going to multiply those exponents together, and 2 times 3/2 is going to cancel. That's like 2 over 1 times 3 over 2. These 2's are going to be canceled, and so we're left with just 9 to the 3rd power. And then over here, that's like 2 over 1, 6. And you can think of this as 6/2, or you can cancel the 2's, but either way, you end up with a to the 3rd power. 9 to the 3rd power is 729, a to the 3rd. So for each of these, it's going to be helpful to think of the number as a power. So 125 is 5 to the 3rd power. 9 is this 3 squared, and 64 could be thought of as 8 squared, but that's not going to help us with the cube root, the radical on the bottom, or 3 on the bottom, but 4 to the 3rd would. In this last section, we are writing each expression in radical form. So instead of having a rational exponent, the fractional exponent, we're going to write it in a radical. So remember, the top number is the power, and the bottom number is the radical or the root. When the power is 1, you don't really have to write anything there. That's going to be equal to 5a. That could be raised to the 1 power, even though that doesn't change anything. And then the denominator is your root. So really, you would think of this as the 3rd root of 5a. You are going to do that for each of these other problems.